All right, so hi, my name is Ari Elias Bachrach. I'm talking about CSRF attacks and mostly, frankly, CSRF defenses. A little bit about me. I'm an application security nerd. I'm an OWASP fanboy. I love events like this. I spend most of my time sort of existing in the space between security and development. I spend a lot of time working with developers, trying to help them make applications more secure, trying to help them understand security. And I also spend a lot of time with security, trying to help them understand development. I often get a lot of phone calls from developers because of this, saying something like, help, how do I do X? Or how do I do X without doing Y? Or help, I did X that you suggested in that developer training class I took last week, and now Y awful thing has happened, which is one of the things that has sort of led to this talk here. When it comes to CSRF attacks and defenses, there are a whole lot of very common defenses that people use. A lot of them have unintended side effects or unintended consequences. And a lot of them, and again, what we're going to do in this talk is sort of go through a whole bunch of them and show you what exactly these defenses do. Again, there's always vendors, many of them right next door, who are happy to sell you some box with a blinking light and say, just use this and it will absolutely defend your applications against CSRF attacks or whatever it is they're selling. Once you actually understand how they work, you understand that there may be some consequences. Those consequences aren't necessarily relevant, and again, a lot of it has to do with the right fit for your application. And I don't want this to be taken, any part of this talk to be taken as a criticism of any of these solutions that we're going to talk about. Most of these solutions, frankly, are very good, but most of them also only work 80% of the time. So it's simply incumbent upon you as the application owner or developer or whoever it is that you are to make sure that your application, if it's not one of the 80% that this solution is intended for, maybe you need to find a different solution. To make sure that you don't end up somewhere, if you're in that 20%, you could have some unintended consequences, you could break some functionality, and we all know that as soon as some security control conflicts with functionality, security control goes away and is never invited back. So anyway, what we're going to talk about in this talk, or what I'm going to talk about, first just cover what is CSRF. Quick show of hands, how many people here don't know what CSRF is? All right, I'll do that part very, very quickly then. What is CSRF? Go through the general high-level fixes first. That's sort of the general principles. And then we're going to get to the bulk of the talk is going to be down here, code-level defenses and server-level defenses, where we're actually going to talk about specific fixes, specific implementations, and show you how the choices that specific vendors have made could impact your application. All right, so briefly, what a CSRF attack is, or at least one way to think about it, perhaps. It occurs when an attacker tricks a user's browser into performing an action on, some target website. So when we think about it, what we need to think about is how does the web work usually? So usually, if you have some sort of a form, could be generated with this code here. You have form action equals something. You have a couple inputs. You have a submit button. User opens up their browser, goes to this page, puts some data in there, and clicks on the submit button. When they do, their browser will automatically generate a packet. If the method is post, it'll generate a post, which will send those variables to the server in the post. If it's a get, it'll just generate a slightly different packet, including those variables in the get. When the server receives this packet, the server does what it's supposed to do. Okay, user sent me this, filled in this data, sent me these variables with these values. I'm going to do whatever it is I'm programmed to do when I receive this information. So the problem is that you can fake this. Or more importantly, if you can predict every parameter in a transaction, then you can fake it. And that difference is actually very important. If you want to fake a get, it's very simple. You can just do something like an image tag. And there are other ways too, but this is a very common one. So if I do image source equals, and then this URL here, the browser will do the same thing. Excuse me. Excuse me. All right. So if you have a page, you have this image source equals and this URL right here, browser will generate that exact same packet we saw on the previous slide. It'll send out a get. It says, oh, look, there's an image tag. It's to an offsite image. No big deal. I load offsite images 1,000 times a minute. That's what I do. I'm a browser. So I'm going to send the get request to server.com with those, to that page, with those variables, those parameters. Everything is good. Server.com gets that request and does exactly what it's supposed to do. Again, whatever it's been programmed to do when it gets a request from you know, from this browser with these variables, these parameters. If you're doing a post, it's just a little more work to do the attack, but it's the same basic principle. What the attacker does is they create a form, and then they just submit it with something like JavaScript. So again, going back to using the same example, if I want to submit a form to this page here, submit page, using a post, with these variables having these parameters, I create the form, I put in the values, and then I just do script document dot whatever the form name is dot submit. As soon as someone's browser loads this page, their browser will generate that form and submit it off to the legitimate server. That's how cross-site scripting, that's how a CSRF attack, cross-site request forgery attack, works. Basic anatomy of attack is, again, so user with their browser is, you know, goes to some website that an attacker has some control over. Either it's the attacker's site or it's a public site that everyone can contribute to, you know, some forum. Attacker puts something out there, one of those two previous examples. Innocent user's browser tries to load that content and inadvertently performs an action on a legitimate website. One thing to note, by the way, this is especially true when a lot of people try to build solutions that revolve around cookies. A cookie alone won't protect you. And the reason is because when the browser is making its request to the legitimate site, again, think about the way browsers behave. Browsers send cookies with every request, if there are cookies. But if there's a cookie for that legitimate site, it's going to be sent with every request. So for example, if this, you know, user here is logged in to the legitimate site and they have a session cookie, that session cookie is sent with every request, even if that request came from or was generated by the malicious page. So a cookie alone won't protect you. All right, so that's CSRF attacks. Now we start the good stuff, the defenses. By the way, extra nerd credit for anyone who knows why this image is here. Nerd credit is exchangeable next door in the vendor room, by the way. No one? So if you ever take the design patterns class in college, you probably get a book called the Gang of Four book, which is the book of design patterns, and this is the image on the cover. It's an MC Escher, it's the MC Escher drawing swans. But anyway, so that's, I couldn't think of a better image to have here. So anyway, there's 4 basic patterns that people use to defend against CSRF attacks. One is called the synchronizer token pattern. Another one is called double submit cookies. Another one is a challenge response system. And then the 4th one is to check the referrer header. So we're just going to, again, talk about these each briefly and then go and see some implementations of all of them. The synchronizer token pattern is the most common defense. It's the official defense for cross-site request forgery. The idea is very simple. So I said before, if all the parameters of a transaction were predictable, they could be faked. So what's the easy solution to that? Make at least one parameter unpredictable. If at least one parameter can't be predicted, an attacker can't fake it. So for example, if you were to generate a form like this, which, you know, this is some sort of a, you know, a form that generates email, you can predict the first 2 parameters, but this last one, if you generate at, you know, at runtime or at load time, some random value that's generated randomly by the application, and that's, you know, just saved as a hidden value in the form, all of a sudden some attacker trying to fake this form can't fake it because they don't know what this value should be. So let's say it's generated randomly every time. Server obviously just has to do the comparison and make sure that the value is what it thinks the value should be. Things to look out for once you start to look at implementations of the synchronizer token pattern is how are tokens remembered? So how does the server keep track of what are valid and invalid tokens? And then also completeness of coverage. Again, a lot of solutions try to take shortcuts when they make decisions about whether or not to insert that token in certain places. So you've got to make sure, so you've got to look at that too. The second defensive option is called double submit cookies. So I said a cookie alone won't protect you, but a cookie with something might. So what you do here is you take a value, again, randomly generated. It could be per user, per session, per page load. This is usually done per session. You store that value in 2 places. One is a hidden form field, and the other one is in a cookie. And what the server does is whenever it gets a request from the client, it checks to make sure that those match. And the idea of this is simply that the server doesn't have to remember. It's very similar to the previous one. You'll notice again there is a hidden form field which contains some sort of random or pseudo-random value. But now the server doesn't have to remember what values are valid and which ones are invalid. It simply compares to the cookie. So again, if an attacker was trying to fake a transaction, the cookie would go along automatically with the legitimate value, but the attacker hopefully not know, unless there's some other problem, shouldn't know the value of that cookie. Therefore, they can't fake the value of the hidden form field. Values won't match. Server rejects it. Things to look out for: do not use the session ID for this purpose. We've spent a lot of time, by which I mean decades, trying to protect session IDs. Don't start exposing the session ID by suddenly putting it in a hidden form field. You're solving one security problem by creating a much bigger security problem. I haven't seen any frameworks or libraries that actually do this, but I have seen people give advice on places like Stack Overflow that say, oh yeah, just use the session ID for this. And then, so some custom, people making custom code may have done this. So if you're doing custom code, don't do this. And as I said again, I haven't seen a framework actually do this. So the reason is you're creating a larger problem than you're solving. So session IDs need to be protected. They're what basically give the person access to their session. So and one of the things we do with session IDs is we put them in a cookie, we make the cookie secure, we make the cookie HTTP only, we set the domain of that cookie, we try to do things to protect that cookie. Now all of a sudden you're putting that very, very valuable session ID, you're putting it in, say, a hidden form field, or you're putting it in the URL if it's a get. You're putting it in all these other less secure locations when you really want to keep this very valuable thing only in a very secure location, relatively secure. Sorry, session ID is what?
They're longer lived than the cookies that go along with each form.
Session IDs are longer length than the cookies that go. Oh, longer lived than the cookies that go along with each form. When you say it would be up to you. It's up to depends how you make the double submit. Depends how long you make them live. I mean, that's up to every application. They can set the length, the timeout on their cookies to whatever they want. So. You're saying the session ID is for the whole session, whereas this, it might be, oh, I see, sorry. So, and we're saying double submit cookies. Double submit cookies, I've seen it usually used in places where they also have it per session. And the reason is that it's often used in things like, say, REST API or things like that, where something like the previous pattern simply would be very difficult to implement. So then it's usually also done per session. But again, it doesn't, as you say, it doesn't have to be. It could be a shorter period of time. All right, the third option is any form of challenge response system. I've never actually seen this done just for CSRF defense, but I have seen this done for other reasons, and then one of the added benefits is, oh look, and we're also protected against CSRF. Challenge response is any system like, the very familiar CAPTCHA, where you ask the client to prove that they're a human being and not a computer before you process a transaction. So that obviously you can see if someone's trying to fake a transaction, the browser sends it off. Well, the browsers can't automatically, submit CAPTCHAs yet, as far as I know. Obviously, there's different options here. There's CAPTCHAs, which I personally hate because I, for some reason, have trouble reading them. I failed the Turing test, go figure. Feel free to make whatever jokes you want about that later. Things like this I happen to personally like better, but again, it's just another thing. It's a small math problem. Verify that you're human. Reauthentication is an option. This one's real. Some banks do this, like if you want to take certain monetary transactions. And again, it's for other reasons, not just CSRF, but CSRF is covered. And then, of course, if you want to be really hardcore, there's emotional CAPTCHAs. So for those of you in the back, I don't know if you can see this with the light, but to complete your web registration, please prove you are human. When Littlefoot's mother died in the original Land Before Time, did you feel sad? Yes or no? So. Yeah, clearly this one needs a little more entropy. It tells bots not to lie, and we all know bots can't lie, right? Things to look out for this is obvious user impact. And as I said, because of user impact, I've never seen this done just for CSRF defense. I've only seen this implemented when there's other things that, people are trying to defend against other sort of automated attacks. All right. And then the last one is the last option is to check the referrer header. I've never seen this implemented for CSRF prevention. I've seen it implemented a couple times in a couple different solutions for CSRF detection. And for detection, it's actually excellent. There are some false positives, which is why I've never seen it used for prevention. But the idea is simply, if you are something like this, like mybank.com, and you get a request coming in for that page, the transfer money page, and you see a refer like this one down here, t.co. Who knows what t.co is, by the way? No one? Come on. It's Twitter. It's Twitter's URL shortener. Yes. So if you see this packet, if you are, mybank.com, and you see this packet coming into your network, this means someone was on Twitter and clicked on a link and got automatically taken to your transfer money page. That's really sketchy. You should not allow this transaction to proceed. So as I said, this is good for detection. The problem is obviously there's just a lot of false positives because there's a lot of things which modify the refer header. There's a lot of places browsers don't respect the refer header. There's various plugins people can install which will strip out the refer header for privacy reasons. So you're simply going to end up with enough false positives that I've never seen this actually done in like a prevention mode, in a blocking mode. All right, so those are the 4 high-level options. Again, singleton token pattern, which is just make one random variable. Double submit cookies, which is to make a cookie and a random variable and have a match. Third one was some sort of challenge response system, are you a human? And then the fourth one was check the referrer header. So now I'm going to go through and see a bunch of specific implementations and how they implement those and sort of where they do good and where they don't. So first one is we're going to cover a couple software libraries. View state user keys, not really a library, but it's a feature built into .NET. Anti-forgery token for .NET MVC. Anti-CSRF, also .NET. CSRF guard, which is for Java. That's actually the OWASP. OWASP made the CSRF guard. And then finally HDiv, which is a it's a Java security library, which I've found to be growing in popularity. And it includes a bunch of features, one of which is CSRF defense. All right, so first one is view state user keys. How many people here, by the way, deal with .NET a lot? Couple, not a lot. All right, guess it's old. I don't know. So this will sound weird, actually, to the non-.NET people. So in .NET, there's a view state. View state, it's a variable, it's put in a hidden form field, and it's meant to maintain, basically, if you're in a page and you're filling out information, it's meant to maintain your state within that form. So the way .NET is sort of intended to work, classic .NET, is that you have a page, it's got a form, you fill out your data into the form, you hit the submit button or whatever it is, and it posts back to the same page. So the submit action is to the same page. Microsoft wanted to defend against a specific type of attack called a one-click attack, which is basically a CSRF attack where it would take you to a specific place within that form. Because of this, they basically built this into the view state. So what they did is they said, okay, view state user keys. So what you do is you turn on view state user keys and it adds the session ID to the view state. And the view state, again, you can configure it to be encrypted, and you should be doing that too for obvious other reasons. What it essentially does is it makes the view state unpredictable, and that becomes your unpredictable parameter. The problem, and this is how you do it, you basically put it in the on-init, you basically just turn on view state user key equals, the session ID. And you can also do this in a base class so that you don't have to do it once for every single page. The problem with this is, as I said, it was meant to defend against one-click attacks, which only work for postbacks. So if you're making a .NET application which uses things other than postbacks for some sort of sensitive transaction, if you have a page where the action is submitting you to another page, it's not going to defend against that. This is actually, it's not going to check the view state and the view state user key on this submission right here, this other submission. And again, for non-.NET people, they're like, wow, that's nothing. Who's ever used a postback? And then the .NET people are like, no, that's like 90% of my applications. So this is, again, this is our first example now, the 80-20 rule. This probably covers you 80% of your sort of classic .NET applications. But again, be aware of the shortcomings, and if that is something that applies to you, you got to find another solution. All right, so what about MVC? So MVC is Microsoft's sort of new model view controller version of .NET. They think it's new and hip. I don't know that Microsoft has ever made anything new and hip. That was unfair. They did once. There's something called the anti-forgery token. It's part of the HTML helper class, and basically you call it just like this. You're creating a form, as the first thing in the form, you put in HTML.anti-forgery token, and it does everything for you. It generates a variable called request verification token. It's a hidden variable, sticks it in the form, generates a random value, And again, you check it on the server side. On submission, you just put this in the controller, validate anti-forgery token, and now this controller is only run if that value matches. So again, these are both examples of the singleton token pattern that Microsoft has given for .NET. Obviously, this only works in MVC. The other problem with this, the other issue with this is that this only works for post. So again, this is fine 80% of the time. So the official RFC spec for the web says that the difference between a get and a post is that gets are supposed to be idempotent, which is a very fancy word for a get should not change anything, any state on the server side. So anything unimportant, I want to get an image, right? Just download an image and that's it. It's just a straight image tag. That's done with a get because it doesn't change anything on the server. Get static HTML, same thing, just do a get. But if you want to do something, if you want to log into a server, so that changes data on the server state, or you want to change the parameters or change a field in a database or change anything or do anything that changes the server state, that's supposed to be done with a get. So if you follow that rule, and again, 80% of the time, you know, people do, it's a good rule, then you're fine. However, if you're not following this rule, this will not by default, it won't by default protect gets. If you want to, however, you can see the source code. That is the line of source right there. And you can, there are people online who have basically modified the source code to make anti-forgery token work with get requests too. You can Google it for details, not going to go into all of them now, but again, that's an option if you're willing to modify the source code, and that's what you need to do. All right, the obvious problem in addition to that is also just the forgetful programmer issue. You got to add this to every controller and every function that needs to be protected. It's not you know, this is one of those things that's much easier to do when you're building the application than to sort of patch, you know, attach it to the application once you're done. All right, anti-CSRF is an open source library. It implements so I'm just going to pause here. So those are the two Microsoft ones. Any questions so far? Microsoft ones? All right, so this is the non-Microsoft solution for .NET. It's called anti-CSRF. It's open source, it's developed in C#, it's available on Codeplex. Frankly, it's pretty nice. It also has no other requirements. It doesn't have to use view state. It doesn't have to be MVC. They designed it to be very, very flexible. It implements the double submit cookie pattern. So what it does, it just creates a new GUID. It's a version 4 GUID, so that's the strong GUID version. It puts it in the cookie and then also as a hidden variable which is submitted in the post. So again, server gets these two things, says, okay, do these two values match? If they match, great. If they don't, stop. It can work in any .NET web app. There's a new token. It generates a new token per session. And again, it does the same thing we talked about before. It only protects the post by default. If you want, and again, it is open source. So if you want to modify it again, that should be very doable. The project, unfortunately, has not been, some people, you know, on the project were asking for a modification that would allow it to do REST, you know, things with the REST API, which all works over GET. And you can see the person who runs it was like, yeah, that's a good idea. The problem is that's the last activity that then happened on the project, and that was about 3 or 4 years ago. So if anyone wants to, you know, fork it and modify it, that would, I'm sure, be very welcome. All right, moving out of the .NET world. CSRF Guard implements the synchronizer token pattern. It's made by some organization called OWASP. It was originally done in Java. There are PHP and .NET ports in progress. It makes a new token per session. Again, it's open source, so it's very flexible. So almost anything you say can be changed because, you know, you can configure it any way you want. Keeps 1 token per session, stores that token in the session. Obviously, the downside to that is simply that if that token is in any way compromised, then the rest of the session, I should say the CSRF tokens for the rest of the session are compromised. So it's meant to be a filter. You drop it into Apache, or Tomcat, sorry, and it modifies existing GET and POST requests. So the advantage to this is you don't have to touch your code at all. I mean, if you have something that's, you know, closed, you know, you bought from some vendor, God knows how many years ago, it's running on Tomcat, and you need to now protect it. You know, it's some legacy thing. You don't even have the source code to it. The vendor that made it is now out of business, and no one knows where the source code is. You know, it's great. You can drop it. You can just drop in this filter into Tomcat, and it'll take care of it at runtime. Yeah. And it'll take existing get and post requests. So every link will just have basically a thing appended to it. Every action will again have a token appended to it. And again, it's being handled at the server level. I could have put this one either in the code section or the server section. It kind of straddles both sides. But so it does everything on the fly at runtime. It can also be configured, so I said that's per session. It also can be configured to generate a new token for each page. The feature is still somewhat experimental and comes with the usual warnings about that, so just be aware if you want to do that, it's experimental, yada yada, disclaimer, etc. But the idea is simply that every link and every action would get its own unique token. It also supports AJAX, which I think is actually kind of cool. What it does is it sets the token value in an HTTP header. Again, what you have to do is you can just configure it in this file here, in the config file. It sets the token as an HTTP header, and again, that's how the server can get the token from the client. All right, any questions on either of those two? Or anything, yeah? Right, exactly. So so the comment was making the token unique per page is just to reduce the scope of each token so that if the token is compromised, there's less of an impact, there's less of an exposure because there's less stuff that can be CSRF'd. So yeah, exactly. That's exactly what it's done for. Yeah?
How often do these projects get updated?
OWASP CSRF guard, I cannot remember off the top of my head. Sorry.
Because for enterprise environments, basically a showstopper.
If it's...
Updated for like 2 or 4 years. So I think it's
Yeah, I apologize. I can look that up afterwards. I apologize. I don't know. I don't remember off the top of my head. Yeah. Right. So the comment was when you do a unique token for each page, it becomes like double submit. It doesn't, because double submit. The idea of double submit is that the value is in a token or is submitted in the get or the post, and then also a cookie. And this doesn't use cookies at all. Right. It's stored in the session, or in the case of this, multiple values are stored in the session. And then when and then it's submitted here, as you can see, in either the get or the post. Right. Yeah. All right. HDiv. As I said, this is it's one that's been growing in popularity amongst Java programmers. I've had more and more developers call me and ask me questions about HDiv. I think it's great, by the way. I love it when developers call me and ask me security questions, because I know that means we're clearly getting somewhere. It's a Java library, provides a whole bunch of security functions. The only one we're going to talk about today, though, at least, is CSRF defense. It also uses the synchronizer token pattern. As I said, that's the most common one. That's the one we've been talking about pretty much exclusively until now. We will show some examples of some of the others in a few minutes. It generates a unique token per link or per action. It then keeps a queue of them, again, in the session of valid tokens. The queue includes all generated tokens, and again, depending on your application, if your application has a lot of links and a lot of forms, this could be dozens and dozens, it could be hundreds per page. So and that queue size, by the way, is also configurable. So make sure you take a look at that queue size and test it with your application, because if you have, and we'll talk about this more for one of the other examples coming up, but if you ever have what the user thinks, what the client thinks is a valid token, and it's not in your queue, they're going to have their request blocked. And we'll see how that can happen coming up soon. But again, pay attention to queue sizes. I've heard from some people that like 50,000 is a good one for HDiv. But yeah. Default, I think, is, I don't want to say because I don't remember, but it's a big number. All right, so these are the libraries. These are the code, sort of the code solutions. These 5 libraries all have slightly different approaches to CSRF. View state user keys, .NET, synchronizer token pattern, only postbacks, anti-forgery token, .NET MVC, synchronizer token pattern again, needs a lot of code changes, got to actually put it in on every page. Anti-CSRF, open source, double submit cookie pattern, only protects posts. CSRF guard for Java, also synchronizer token pattern, can be done per session or per page. And HDiv, also the synchronizer token pattern once per every single link or action, queue-based expiry. All right, going to pause here because there's been a lot of things thrown at you. Any questions about any of these 5 or anything you've seen up till now? Okay. Oh, yeah?
HDIV, how is it implemented? Also a filter?
No, so HDIV, how is HDIV implemented? HDIV is a library, so it's a library you would download and import into your project.
Okay.
All right. So we can also do, as we sort of got some hints of with CSRF guard, we can also do CSRF protection at the server level, or sometimes even at something like the load balancer level. And again, this is very good. I work in a lot of environments where, we've got literally thousands of applications. These things are existing, many of them are legacy, and there simply don't exist the money or the man hours or whatever it is to go back and edit 2,000 web applications to start putting in CSRF defense. So some of these can be very good for that. So Tomcat 7 now includes a CSRF prevention filter. In many ways, it's actually very similar to OWASP's CSRF guard. So OWASP's, by the way, was first, in case anyone's keeping track. It generates a new UUID for each page loaded. Again, it's a filter, so it's a configuration option. You turn it on in Tomcat. It acts just like the filter, very similarly to the CSRF guard filter. Protects all gets and posts. Again, it modifies the links at runtime. So you've had this application running in your environment on a Tomcat server for, 10 years now. All you need to do is upgrade to Tomcat 7, change the configuration, and it will do all this at runtime for you. All of a sudden, all these links will start including a nonce, sort of like this one here. The default value is this horrible, horrible name of org.apache.catalina.filters.csrf_nonce. And for some bizarre reason, that value is not, you can't change that. You can, it's all open source, so you can modify the source, but it is not a configuration option to change the value of that horrible, horrible variable name. Protects gets and posts, as I said, and it stores the last n values in the session. The default value for n is 5. So now this is probably the one I get the most calls about, like, help, we did this thing you said to do, we, did some CSRF defense, and now, the business is complaining because we broke something. So the problem with something like, 5, only storing 5 values is what if someone opens up a second tab and then makes 6 mouse clicks and then goes back to the first tab? Or what if they are navigating their application and then they hit the back button 5 times? So so this goes back to what I was saying before. If the client thinks they have a valid token value and it's been pushed out of your queue on the server side, you're going to break functionality. And again, we all know what happens when security conflicts with functionality. Security goes away and is never invited back, no matter how many times you try to convince them that you fixed the problem. The business will never trust you again. You will never be allowed to fix that problem again. So don't get caught in that. Again, it is configurable. I didn't put it in here. I forget what the maximum value is now. I'm pretty sure, I can't remember. I forget what the maximum value is, but take a look. But as I said, that is configurable. All right, load balancers. So load balancers can also do, sorry, I should say F5, the ASM is F5's application security module. It's basically something you can, if you're using an F5 load balancer, you can basically buy this and it'll go on your load balancers and give you a lot of application security functionality. One of those pieces of functionality is to implement the synchronizer token pattern. So sort of similar to the last solution we saw, it takes the form action, it takes this link, again, it does gets and posts, and automatically puts in a value or a token in here. And again, this is all done, this isn't even done on the web server at all. Web server is completely oblivious to this. So again, it's a very good solution for lots of legacy apps that are running in your environment. Load balancer does the checking and will reject the packet if this token, CSRT is, CSR, cross-site request token, I guess. And it'll block it if the value isn't what it should be. Protects all gets and posts. Tokens are generated per session, and this does a time-based timeout. The ones we've seen up till now, HDIV and Tomcat, both did a queue-based timeout. This one's doing a time-based timeout. You can configure that from 1 to 99,999 seconds. Excuse me. Default is 600 seconds, which is 5 minutes. No, sorry, 10 minutes. I can't do math today. Obvious problem there is just, again, watch your timeout. If you break real functionality, if, you have an application where people are regularly logged in and walk away from their keyboards for 11 minutes, up that timeout. All right. Then the last one is Imperva's Secure Sphere, which is Imperva's web app firewall. So this is the only one I mentioned before that I had never seen this used actually in blocking mode, the checking the referrer header. And as I said, this is the only thing that I know of that actually does it. Basically, it checks the referrer header on all requests, and if it sees a referrer header that it shouldn't, it alerts on it. And again, it's it's configurable. You can set it into alert mode. You can set it into block mode. It'll do whatever you want it to do. As I said, I've never seen it. I've never seen anyone actually put that up in block mode simply because of the number of false positives it generates. But again, if you've got a human being looking over your Imperva alerts anyway, they're probably used to getting false positives. So, you had a question?
Does it come packaged with some templates for the sites that recommend you not accept?
The question is, does Imperva come packaged with some templates recommended for the sites you not accept? You mean like specific referrer headers that should really set off alarms? It doesn't. It basically just says anything off-site. It says if I get a post that's coming from off-site, that's weird. And again, that is sort of abnormal behavior. When's the last time you, sitting down at your browser, logged into your whatever account by sending a post without first getting the page that generates the form that had the post in it? Yeah?
Particular question is the first one regarding the content implementation of CSRF. You said it creates tokens per page.
And let me finish Imperva, and then we'll go back to Tomcat. Is the other question about Imperva? Or no? Okay. All right. So the problem with this is simply that the referrer header, as I sort of hinted at before, it's not respected in all situations. There's a lot of odd. If you've never looked at the rules about when the referrer header is sent or not sent when based on an HTTPS session, take a look at that. Just to give you an idea of sort of when the referrer header might not be present. This could break bookmarks potentially. That's also, in some situations. But then again, why is someone bookmarking the post? There's a lot of plugins that can stop or tamper the referrer header for privacy reasons. So all these could cause false positives, which is again, with reason, as I said, I've never actually seen this put into blocking mode. All right, so the summary of this, and then I'll go to your questions. So Tomcat, synchronizer token pattern with a queue-based expiry. F5's ASM, synchronizer token pattern with a time-based expiry. And Imperva is the only one of our group so far which checks the referrer header, largely used for detection, haven't actually seen it done for prevention. All right, questions on these?
Five tokens by default at the page level.
Sorry, Tomcat is 5 tokens. It's stored in the session, so it's per session.
Session level, it's not the edit at the page level, so I was wondering.
Yeah.
And besides the Tomcat site, do you have a good link for a quick config on Tomcat anywhere else besides the Tomcat site, or is there still good?
Question was, do I have a quick link for how to configure the Tomcat CSRF filter? Honestly, Tomcat is very well documented. I mean, if you search if you search, I'm sure you can search the internet and find people who are discussing it and post up examples, but Tomcat is just well documented, so. All right. Any other questions on any of these 3 or the previous 5? Anything else? Yeah?
In the real world, which one do you see working the best?
In the real world, which one do I see working the best? The answer is it really depends. Again, a lot of these, all of these, we've talked about 8 options now total. All of these work in a lot of situations and don't work in some other situations.
I mean, out of these 3, obviously the Imperva one is really that usable since it just alerts, it's not going to prevent.
Well, you can put the Imperva in prevent. It's just that I've never seen anyone do that because of the number of false positives. So, which one do I see working the best? Of these 3, I'll bet you the one that's most common, and this is, I haven't actually checked, but of these 3, the one that I'm guessing is the most common is probably Tomcat, simply because Tomcat is free and widely used, and Imperva is less widely used and costs a lot of money, and F5's ASM is also, it's simply not as widely adopted. Those bottom 2 are only useful if I wouldn't, not that I make anyone's purchasing decisions, but I've never seen anyone purchase F5's ASM just for CSRF defense, or, Imperva's WAF just for that, so. So some other general advice when implementing any of these. CSRF token names can reveal what library you're using. So just try Googling something like this. In URL, org, remember I made fun of that horrible name for the Apache token, org.apache.catalina.filters.csrf_nonce. So Google for it, and you will see a whole list of websites. Now you know exactly what sort of defense they're using. So this is another example. You can Google, this is the OWASP CSRF token. So you can Google in URL OWASP CSRF token and see everyone who's using the OWASP CSRF guard. And again, now you know the attacker now knows exactly what's going on. And because this is an OWASP conference, I should mention, Tomcat gives you 500 results as of whenever I took the screenshot, and CSRF guard is 126,000. So kudos, as I said, CSRF guard was first. So kudos to the people who made that. So that also brings up another thing. If you have the ability to configure, depending on which solution you have, to change the name of your token, it's probably a good idea. Can't hurt. All right. Almost all the solutions we've mentioned now that use tokens allow you to customize the name of the token. Some of them require you to edit source code to do it, but there's usually some way to do it. So again, so look into that. Another thing just worth pointing out, if you have a single cross-site scripting flaw on your website, everything we've talked about up till now becomes useless. It's actually, I'm pretty sure if you check the OWASP CSRF cheat sheet, you'll see rule 0, before they even start the rules, they're like, rule 0, have no cross-site scripting. It's just, any cross-site scripting vulnerability will allow people to access your cookies, your form values, whatever it is. Everything we've talked about becomes just an absolute pile of useless garbage if you have a single cross-site scripting vulnerability. So if you're trying to stamp out CSRF, you better make sure you have cross-site scripting eliminated first. CSRF tokens can also be leaked through referrer headers, and they can still be reused if they're still valid. So if someone's on your site, if you've got your CSRF tokens in it, if you're protecting gets, and this actually gets to another thing. So I talked about the importance of making sure you have complete coverage for some of those ones that only protect posts. Don't protect gets unless you actually really need to. And again, in an ideal world, you should be following the RFC, and gets should be idempotent, so they shouldn't change server state, so you shouldn't need to protect a get request. But if you do have an app where you do need to protect a GET request, this is one of the other sort of side effects to look out for, is the fact that someone using your application, making a click off the application or going somewhere else now, all of a sudden that other web server is going to get a copy of your CSRF token, your valid, I should mention, CSRF token. All right, know your defenses. Which solution you select, either one of these 8 or there are others out there, and I'm sure there will be more in the future. Picking the solution depends a lot on your application. You've got to know your application. You obviously know it better than the vendor. The vendors will all try to sell you their security box. Here, just take this magic box and it'll solve everything. But you've really, none of these solutions are perfect. They're all excellent, but they're not perfect. And you simply have to know where they apply and where they might not apply to your environment, and where there might be side effects in your environment, so maybe you don't want to pick that solution. A lot of these are also not well documented, which is one of the reasons this talk happened in the first place, is I started looking at all these things as these things started popping up in the real world, and I was like, why on earth does that happen? So hopefully I've helped show some of these side effects. Hopefully I've helped you figure out what should be the right defense to use in your application. You've got to know your environment. Your choice is going to depend a lot on your environment, the language used, whether this is a new app or the retrofit of an old one. Idempotence, again, we talked about that, whether you really need to protect GET requests or not, and the potential user impact of some solutions. There's my contact info. You can email me, you can tweet me. The slides are up on my website. I actually should have put a full URL there, but you can probably find it's defensium.com/CSRF. I've got the slides, and then also the 2 summary charts from this presentation are also up there on the web. So if you want to just refer to those, go for it. Yeah, that's it.